All right. So today I'm going over the notes for chemical quantities, and this is detailing the mole and molar mass. So in chemistry, the mole is a unit for amount of substance. This was an idea that was first thought of by a scientist in the 1800s named Avogadro. That's his last name. He has like 5 names. Anyways, Avogadro had this idea that there was a certain amount of particles or, atoms that could be captured in a space if you had two gases. And it turns out he was right. So that number happens to be 6.02 times 10 to the 23. And the y is just a variable that you can put like atoms, basketballs, donuts. It doesn't matter. It's just this is the mole. So the mole equals 6.02 times 10 to the 23. And then we'll use y. You can use whatever you want. So, how is this important for chemistry? What we're going to be doing is I'm going to start off by explaining what a molar relationship is, and then start by going over molar mass. And you're going to quickly see that this number is incredibly important for determining almost everything with chemical reactions. And when we start going over stoichiometry later on in the unit, you're going to start seeing this. So, anyways, for atoms, let's just say we have 1 mole of carbon. We have 6.02 times 10 to the 23, and then I'm going to do it in blue. Carbon atoms. For molecules, it's the same thing. So let's say we have a covalent compound. Let's say I have 1 mole of carbon dioxide. We now have 6.02 times 10 to the 23 CO2. And then, here, let me do this one in red. So let's change this. CO2 molecules. And then if we have an ionic compound like table salt, we use something called formula units. So what that means is, say I had 1 mole of sodium chloride. We have 6.02 times 10 to the 23 NaCl formula. Wow, that's bad. Units. Sorry, I ran out of room there. All right, so what I'm trying to get at is there's a certain number that I keep writing. Memorize this. It's incredibly important. I will not be telling you about this on a test. So, and it's not going to be on your formula sheet either. All right, so Avogadro's number is a conversion factor. So, write that down. Avogadro's number is a conversion factor. So, on the left, write amount of, we'll just say particles. And then on the right, I want you to write moles. So, number of moles. And then you're going to draw in, this is called an equilibrium arrow, but just saying that traveling in 2 different directions. So, anyways, for the amount of particles you're going to moles, you're going to divide by 6.02. So divide by 6.02 times 10 to the 23. If you're going number of moles to amount of particles, you're going to multiply it by 6.02 times 10 to the 23. I'm going to show 2 short examples, and then there's homework problems for you to practice. All right, so let's write it down. Oh, and let me write this down first. When you're dividing, it's written like this. 1 mole over 6.02 times 10 to the 23. The reason being because you're going to put a multiplication symbol to the left of it because you have something over here in particles. So it's going to cancel out the particles and you're going to be left with moles. So when you're writing by multiplying, it's the same thing. You just write it backwards. 6.02 times 10 to the 23 over 1 mole. Kind of color-coded it for you so you could see it. Now, if you need to copy this, pause it. All right, so how many atoms of calcium are in 3.0 moles of calcium? So how do we set this up? Let me open the calculator real quick. So here we go. So how many atoms of calcium are in 3 moles? So it's kind of like a simple math problem where you really just have to read it and figure out what I'm asking you. So you're trying to find how many atoms. I gave you 3 moles. It's kind of like when they give those weird math problems and some dude bought like 64 pumpkins at the supermarket. And you're like, well, why do you do that? Really, you just need to focus on the number. So when you see the number, write it down. So you have 3.0 moles, right? And then you're trying to find the atoms. So you know that if you have moles up here and you're multiplying by a conversion factor, moles has to be on the bottom. So you're multiplying by the amount, or Avogadro's number, in atoms divided by 1 mole. And this is going to cancel the moles out. So you're going to be left with whatever the calculator spits out, because I'm not doing this by hand. So 3 times 6.02. And you're going to need to remember, EE stands for times 10 to the power of. So you need to be familiar with your calculator. Casios use something usually by the equal sign that'll say like times 10 to the power of, but for Texas Instruments scientific calculators that I recommended, there's a button that says EE. It's either second EE or it's just a button that says it. So anyways, the answer should be about 1.8 moles, or 1.8 times 10 to the 24 atoms. And then that's of Ca. Sorry, I misspoke when I said moles. So if you need to kind of see that, just pause it for a second. All right, so second one. How many moles of silver, which is Ag, are in 4.8 times 10? I think I wrote, 10 to the 23 atoms of Ag. All right, so same thing. This is what I gave you right here. You need to write that down. 4.8, and then that's times 10 to the 23 atoms Ag. And then remember, atoms goes on the bottom, so your moles has to go on top. So 1 mole divided by Avogadro's number. And then that would be atoms Ag. So you're just going to be left with moles of Ag. So let's plug that into the calculator. So we have 4.8, and then second EE, 23, divided by 6.02, second EE, 23. And you're going to get about 0.8 moles. And then that's it for understanding the basics of going from moles to particles or atoms or whatever. So now, here's where it's not really much harder, but it's another skill that you're going to need to learn because this is really important. All right, so we're going to be talking now about the molar mass. So the molar mass is exactly what it sounds like. The molar mass is equal to the mass of 1 mole of an atom, compound / molecule, or formula unit. Really, nobody says formula unit. I've almost never heard that, so you can just kind of disregard that for now. Just worry about the compound molecules or atoms. So, mass of 1 mole carbon is also the mass of 6.02 times 10 to the 23 atoms of carbon. So let's do this. So remember when we went over the periodic table, you had your atomic number on top and you have your atomic mass on the bottom. So interesting thing about your atomic mass is it is also your molar mass. So your molar mass is, let me do this. Your molar mass is in grams per mole. So if you have 1 mole of carbon, you have 12.01 grams of carbon. That's how that relationship works. So for carbon, so let me preempt that. For carbon, 12.01 grams equals 1 mole equals 6.02 times 10 to the 23rd atoms. All 3 of these are equal, and you can convert back and forth between them. I'm going to show you a problem later where that's what we're going to be doing. So if you need to see that, just go back and pause it. Or you could print the notes out beforehand, either way. So anyways, molar mass is also a conversion factor. So is a conversion factor. So on the left, make sure you copy this down. So you have moles, and then you're also going to have grams. And I'm going to write the metric system symbol for this. And moles is just usually like, you'll see MOL. That's why I write that a lot. So anyways, let's do those arrows again. I'm going to do an equilibrium arrow. All right. So if you're going from moles to grams, you're going to, let me do this in blue, multiply by molar mass. If you're going from grams to moles, you're going to divide by molar mass. So, how does that work? Here's an example. How many moles of carbon are in, I'm going to do a different one. So how many moles of carbon are in 47.8 grams of carbon? So you could literally do this for any number. It's all going to be able to be solved because we have constants like Avogadro's number, molar masses, all this stuff. So remember, 47.8 grams is what we have. So 47.8 grams of carbon, and then times 1 mole over 12.01 grams. So carbon, carbon, carbon equals, we're going to cancel out the grams of carbon on both of those. You're going to end up with a fraction that's 47.8 over 12.01. And that's in moles because we've canceled the grams out. So let's clear this. Let's do the math in the calculator. 47.8 divided by 12.01. And you're going to end up with approximately 3.98 moles. And that would be your answer for this case. So as you can see, the molar mass is kind of important because your moles are what are represented when we do chemical reactions. All those big numbers that are in front of molecules, those are moles. All right, so I'm going to give you another one. How many moles? Oh, wait, no. I'm going to do grams this time. How many grams of iron are in, I don't know, 5.23 moles? Do different numbers in case you're rewatching this so you can see it again. So, again, we are given 5.23 moles. And Fe is iron. That's number 26. The molecular mass, or molar mass, is 5.845 grams a mole. So 5.23 moles times, we're going to multiply it by the molar mass because it's grams over 1 mole. It cancels. 55.845 grams over mole. And this is going to tell us how much iron we have in grams. So let's do this in the calculator. Clear it. 5.23 times 55.845. So we have 292.07 grams of iron. That would be your answer. So, like, these calculations don't usually take that long to do. Now, there's one more thing that we have to go over for this. And then tomorrow we're going to go over some problems, multi-step problems, where you're going to have to think and, you know, kind of look at them a little differently. They're not all going to be so straightforward. So this one, we're going to use carbon dioxide. So calculate the molar mass for compounds. So this is easy. You simply take all of the the subscripts that are on the molecules, and you take all of the coefficients to count. Actually, let me rephrase that. So let me write it down because I'm going to confuse myself. So pretty much you're counting how many of each atom there is, or each element there is in the molecule, and you're going to multiply that by the molar mass. Remember, if there is no superscript or coefficient in front, it's just 1. So for carbon, we have, I don't have a periodic table in front of me, so I'm going to estimate. So we have 12 grams, and then that's times 1. And then over here, oxygen is 16. So 16 times 2, because we have 2 of them. And we sum them up. So we add them. So we have 12 plus 32 equals 44 grams per mole. And that would be your molecular mass. You can do this for any molecule. It doesn't matter how big it is. So like for instance, I could do glucose. So same thing. This is 12, 1, and then this would be 16. So 12 times 6, H times 12, and then 6, or 16 times 6. So you add these up. So you did 12 times 5 is 60, plus 12 is 72. So 12 times 6 is 72 plus 12, and then 16 times 5 is 80, and then you add 16, and that's 96. And I'm going to double check this in the calculator, but I'm pretty sure it's right. So this is 84 plus 96, and then 90 plus 80 is 170 plus 10. So that would be 180 grams per mole. And this is very rough because it's all, this isn't exact from the periodic table I just estimated, but it's roughly equivalent to 180 grams a mole. On a test, usually I'm going to give you the molar mass of something, but there are chances when I'm going to make you do everything. Maybe a free response question or something like that. Now, I'm going to leave you with 2 problems and see if you can figure the answers out. So, let's see. Calculate the molar mass of, let's do magnesium phosphate. So this would be Mg3 2. So, and then this would be in parentheses. So if you don't know your polyatomic ions, I know I didn't really test you on those. There are a lot to learn, but you're going to need to know the ones that I highlighted. And maybe I'll talk about that a little bit tomorrow. But anyways, phosphate's is a polyatomic ion due to charge. If I was asking you to calculate the molar mass of this, you do it the same way you do anything else. So magnesium, I don't have a periodic table. Let me look. Magnesium, if it opens. Of course it's not going to open. Alright, so let me just double check. I want to say magnesium is like 24 point something. I'll just put 25 to make it easy. So I'm going to guesstimate that this is about 25. Just for the example, multiply it by 3. Actually, let's do 24. It's 24 multiplied by 3. Then this you can easily guesstimate too. Actually, probably not. 16 times 4, and I think that's about 32, 33 or something like that. Yeah, so we'll just do 32, 33, and then plus 64, because oxygen is 16 times 4 is 64. So that is where I got that number from. Okay, so we're going to say this is about 97 plus whatever this is, and that's looking like it's going to be 72-ish. I know this is probably not exact, but it's just an example. So let's do this. You have 9, and then that's 169. And that's very rough because I'm kind of guessing on what the atomic masses would be of magnesium and phosphorus. But that's kind of how I'm going to be expecting you to do it, where I might ask you how many moles of something you have, or how many, units. Like, you're going to have to be able to convert back and forth. All right, and that's it for the notes tonight. If you have any questions, just ask in class.